Hi everyone, welcome back. Good evening to all of you. Hi everyone. Welcome back. Let me know in the chat box if I'm clearly audible and visible. Hello. Hello. Good evening. Welcome back. How's everyone? How are you all? Hi. Let me know. Yes. We have started our class. All right. Very good evening. Perfect. Audio, video, all good, right? Great. All right. So friends, today we are going to start basic mathematics. We are going to start and we are going to complete, right? All the Yakeen students know, Yakeen NEET English students know. We have already completed this chapter. All the students who are from Laksh NEET English, let me know in the chat box. We are keeping this class specifically for our Laksh students, but because it's on YT, it's available for all of you. We are going to start with trigonometry, right? We are going to start with Trigno, and as promised, we'll start from the very basics, zero level. We are going to talk about everything under trigonometry, and then then the major part we are going to give to major time will be given to calculus, right? Differentiation, integration, everything, and then we are going to also discuss algebra part. We won't be able to complete vectors today, so I'll keep a separate live class for vectors as well, right? Good evening. Hi Pallavi, hi. Write down your name also, hai na? Satya, hi Satya. Hi Mani. Hi Mamta. Hi Rovi. All right. Hi everyone. Hi Harish. I can see your names. Hi Nitya. Steward. Hello. Hi. Come on. Great. Hi Nishita. Hi. If I'm missing anyone's name, sorry. Should we need to note in our notes as well? I mean, if you are part of Yakeen batch, then no, notes are already with you. If you are from Laksh student or any others from any other batch, you can prepare notes, right? And I'll try my best to give you these notes through WhatsApp channel also, right? All right. Hi Pragya. Hi Shyam. Hi Anam. Hi everyone. Hi Supriya. Hi Sham. Good evening. Chalo, let's begin. So we are going to start with the very basic definition of angle, right? I'm starting the class. Let's talk what do we mean by angle, right? What do we mean by angle? My dear friends, let's suppose we have got a line over here. And this point is fixed. This is a fixed point. This is a fixed point. And we are trying to rotate this line. We are trying to rotate this line. And let's suppose we try to rotate it somewhat like this. Got it? Now when you are going to rotate it, the amount of this rotation is known as angle. The amount of rotation or revolution is known as angle. When you are going to rotate it, we can also imagine that this will trace an arc. This point, please note, this point will trace an arc. That means a line like this, right? This is called as arc length. This length of this thing is known as arc length. And let's suppose this point is A, this point is B, and this point is O. So arc length will be written as AB and a arc over it, just to represent that we are talking about arc length, right? So the formula is for theta, the formula will be arc length divided by radius, divided by radius. Let's suppose radius is r, that means let's say the length of this line is r. So we are going to say AB divided by r, AB divided by r. We can also say that arc length can be written as theta multiplied by radius, theta multiplied by radius, right? As you all can see, this is also a length, this is length, radius is also nothing but it is also a length. I mean, it will have the dimensions of length only, right? That means when we are going to talk about the dimensions of theta, theta will come out to be dimensionless, theta will come out to be dimensionless. It won't have any dimensions. Dimensions of theta is going to be n0, l0, t0, everything raised to the power 0. From 10th class, you remember this formula that arc length can be written as theta multiplied by r. Now let's move on. If we are going to, let's suppose if we are going to rotate this line and we are going to rotate it and make a circle, so we'll get something like this. We'll get something like this. Is that clear? Let's suppose you start to rotate a line of length r. This length is r and you start to rotate it and we reach at this point. Everyone knows that this angle is known as, this complete angle will be 360 degree angle. This complete angle will be 360 degree angle. Yes, we are going to talk about graphs as well. And if I'm going to now talk about, let's say this point was A and this point, another point is B, same point. Then in this case, the arc length will be, in this case, the arc length will be 2 pi r. That is circumference. This is nothing but, my dear friends, this is circumference. Circumference, right? If we are going to relate this formula, that means 2 pi multiplied by r with theta multiplied by r. From here we can say that theta in radians, theta in radians is equals to 2 pi for 360 degree. That means this is theta in radians, it is 2 pi, or if we are going to talk about in degree, same 2 pi can be written as 360 degree. Same 2 pi can be written as 360 degree, right? Which means that now we are going to talk about conversion. 2 pi radians, right? I'm not writing radian, but please understand this is 2 pi radian is equals to 360 degree. From here we can talk about all sorts of conversions. From here, my dear friends, we can talk about all sorts of conversions. Let's see, because this is very easy and simple. I am going a little fast. If you have got any doubt, you can let me know in the chat box, right? So 2 pi is equals to 360 degree. This is very, very simple and easy. Everyone remembers now how we have got to this point. Arc length is 2 pi r. Just now we have written it that any arc length can be written as theta multiplied by r. Please remember this, whenever you are going to write down this theta will be in radian. This theta will be in radian. Almost in every other chapter in physics, hi Robin, hi everyone, hi Mahira, hi. In every other chapter, we are going to only talk about radians. If let's suppose in question they have given you in degree, we'll quickly convert it into radians, right? So 2 pi can be written as 360 degree. Now, my dear friends, if 2 pi can be written as 360 degree, the next conversion will be 1 radian. 1 radian will be written as 360 degree divided by 2 pi. Divided by 2 pi. That means this is 180 degree. This is it. That means if you want to know what is one radian, so we are going to write it as 180 degree divided by pi, right? Now pay attention. Pay close attention. Pay close attention, my dear friend. Hopefully this is all clear to you. Let's suppose someone tells you to write down 45 degree in radian. 45 degree in radian, or someone tells you to write down pi by 4 in degree. All you need to remember one thing, simply write down pi by 4 and multiply by 180 degree divided by pi. And if you want to convert degree into radian, you need to remember 45 degree multiplied by pi by 180. That's it. These, if you are going to remember this simple thing, if you want to convert radian into degree, simply multiplied by 180 degree by pi. If you want to convert degree into radian, simply multiplied by pi by 180. That's it. And you will get to your answer. Similarly, 1 degree will be actually equals to 2 pi by 360 degree. That is pi by 180 degree. That's it. Right? And now we can talk about all sorts of conversion, and you have got angle conversion over here as well. Right? 1 degree is equals to this. By the way, pi by 180 can be also written as 0.02 radian. Degree to radian multiplied. Please remember, if you want to convert degree into radian, multiplied by pi by 180 degree. If we want radian, pi will be in the numerator. If we want radian, pi will be in the numerator. Right? If you want degree, degree will be in the numerator. So if pi is in the numerator, 180 will be in denominator. If degree is in numerator, pi will be in denominator. Simplest thing, right? Simplest thing. All good. Please remember, 1 degree pi by 180 can be written as 0.02 radian, or 1 radian can be written as 57 degree. This is approximate 57 degree. Clear, my dear friends? Now some pretty simple conversions. If someone talks about 30 degree, everyone remember this is nothing but directly pi by 6. How pi by 6? Simply multiply 30 degree with pi by 180. 0 and 0 gets cancels out. This is 6. Clear? If someone talks about 45 degree, this is pi by 4. That means 45 degree multiplied by pi by 180 degree. So this is going to be 4. Or you can say 9 2s are and 9 5s are, right? 45 degree divided by 180 degree, right? And then you have got 60 degree. 60 degree is going to be pi by 3, or 60 degree multiplied by pi by 180 degree. This is simply 3. 90 degree is going to be pi by 2. 120 degree, remember 120 also, 120 degree multiplied by pi by 180. 0 0 get cancels out. 6 2s are 6 3s are, right? So that means this will become 2 pi by 3. Kindly remember, this is also important. 2 pi by 3. Hopefully everyone remembers these things, but please remember 2 pi by 3. Kindly write down the answers of 135 and 150 degree in the chat box. Also convert 270 degree. Also convert 270 degree. Come on, quickly write down in the chat box for 135 and 150 degree. Be quick. Be quick, dosto. Quickly write down for 135 and 150 degree. For 135, you're going to simply write 135 degree multiplied by pi by 180 degree. I believe we can cancel out with 5. I will share the PDF of this complete thing on WhatsApp channel of PW NEET English, right? This thing is going to be 150 degree multiplied by pi by 180 degree. Pi by 180 degree. You can do it with 3 5s are 3 6s are. So this will become 5 pi by 6. 5 pi by 6. Simplify this as well, my dear friends. Simplify this. 270 degree will become 270 degree. We want in radian. Pi will be in the numerator. That's all I can say, right? Forget about conversion. You want to convert from degree to radian, na? Quickly write down pi over here and 180 in the denominator. 0 and 0 gets cancels out, and then let's take 3. I mean, you can also take let's take 3, 3 9s, or let's take 9. So 9 3s are and 9 2s are. That means 3 pi by 2. 3 pi by 2. So 0 degree, 90 degree, 270 degree and 360 degree will be 2 pi. So remember this. We are going to use this a lot. We are going to use this a lot. This is 0 degree or 0 radian. So when you want to write down radian, simply write it as 0, right? Clear? In almost every chapter, bache, this is useful. This is either 90 degree, angles will be measured like this. This is 90 degree or pi by 2 radian. Then this is going to be, this angle from positive axis is going to be either 180 degree or pi radian. This is going to be 270 degree or 3 pi by 2 radian. 3 pi by 2 radian. Then when we are going to come back to this point, you are going to write it as 2 pi radian or 360 degree. Clear? Done? All good? All sorted? Fill the chat box with yes. Now similar thing, my dear friends. This is obviously 360 degree. This is 180 degree. This is 90 degree. This is 60 degree. This is 45 degree and this is 30 degree, right? This is 30 degree. Very easy. That's why we are also moving in certain speed. Hold on. I have promised there are lots of students who might have tiny doubts here and there. That's why we are moving from 0 level and we are going to complete everything. In 15 minutes, you will see the level of class. All right. But we are not missing these things as well. Now, let's suppose someone tells you to write down 37 degree. 37 degree in radian. So let's suppose someone tells you to write down 53 degree in radian. No worries, my dear friends. We are going to simply say one thing. We are going to say, let's write 37 degree multiplied by pi by 180 degree. This is our answer. No issues, right? I mean, 37 can't be simplified using 18, so there is no problem. This is going to become 53 multiplied by pi by 180 degree. All I can say is that if I have got degree and I want to rewrite, if I want to convert it into radians, in the numerator I'll have pi. That means denominator I'll have 180 degree. That's it. Got it? If let's suppose I have got something like pi by 10 and I want to convert it into degree, then I'll write pi by 10 and I'll multiply with 180 degree because I want to have my answers in degree, and I'll divide it by pi. This is 18 degree. This is 18 degree. Got it? Clear? Let's suppose if we have got pi by 30, we want to convert it into degree. Bhai, if you have got already pi, then obviously you are going to convert it into degree. So if you want to convert it into degree, multiply 180 degree in the numerator and divide it by pi. Pi and pi gets cancels out. This becomes 6 degree. This becomes 6 degree. Right? Becomes 6 degree. Small angle. Anything less than 10 degrees considered as small angle. Just a little information. All right. Moving on. Easy. Clear. Done. Now let's talk about measurement of positive and negative angles. Let's talk about measurement of positive and negative angles, my dear friends. See, these are known as reference lines, also known as x-axis and y-axis. You all know them. X-axis and y-axis. My dear friends, it is a convention. Convention basically means you can take it as a scientific tradition. It's a scientific tradition. What is a scientific tradition? How we measure angles. Let's suppose we have got a line like this. So the scientific tradition is, the convention is that we are going to always measure the angle from the positive x-axis in the anti-clockwise direction. And this type of angle will be regarded as positive angle. This type of angle will be regarded as positive angle. Let me repeat it again. My dear friends. What do we mean by positive angle? angle measured from positive x-axis in anti or counterclockwise direction. So whenever somebody is going to ask you about angle of anything, by default we are going to measure the angle in the anti-clockwise from the positive x-axis, right? This is going to be our theta. If someone does this, let's suppose we have got a line like this, and let's suppose we measure the angle in the clockwise direction, then this angle is regarded as negative angle. This angle is regarded as negative angle. Kindly do not worry about notes. I am going to provide these notes after the class. Don't worry. Okay? Don't worry. This is my word. Alright? Please again understand, positive angle means angle measured from positive x-axis in anti-clockwise direction. Negative angle is angle measured from positive x-axis in clockwise direction. We are going to talk about it later also, don't worry, but usually we always measure the angle in clockwise direction and we write it as positive angle, right? Moving on, this is also very easy, no doubt here. Trigonometric ratios. My dear friends, trigonometric ratios are for right angled triangle. Let's say we have got a right angled triangle like this. First of all, please understand, this is only for trigonometric ratios are for right angled triangles. And these are ratios, not a big deal. These are simply ratios. Let's suppose, my dear friends, this is theta. Then the side which is opposite to this theta, is known as perpendicular. This is known as perpendicular. The side adjacent to this theta is known as base. Side which is opposite to this angle is known as perpendicular. Side which is adjacent to this angle is known as base. This is 90 degree. And always remember, let's suppose this is alpha. So alpha and theta are complementary. You can also write down alpha equals to 90 minus theta. According to alpha, this will be perpendicular. So which is perpendicular or which is base, we will have to comment this based on the angle. Angle will tell us which is perpendicular and which is base. Without angle, it makes no sense to call a particular side perpendicular or base. For this theta, this is perpendicular. For this theta, this is base. There is no doubt about hypotenuse, because hypotenuse is the longest side of a right angle triangle. So this is hypotenuse, right? Now we have got mainly three types of trigonometric ratios. In simple terms, trigonometric ratios are nothing but functions. What are functions? Let me explain this to you. For an example, let's say I am writing y equals to 2x. This is a function. This is a mathematical function. Definition is very simple. When you are going to put some values as input, this can be called as input. When you are going to put some input, we are going to get output based on a particular rule. Or formula. The rule is output is 2 times of input. See, output is 2 times of input. That means if input is 1, output will be 2. If input is 2, output will be 4. If input is 3, output will be 6. So rule is 2 times of x. So similar to this, my dear friends, we have got trigonometric functions also. So we have got mainly 3 types of trigonometric functions. One is sine theta, where theta is the input, and sine is actually a function. Sine is actually a function. It is a rule. It is a rule. And what is that rule? That rule is, my dear friends, perpendicular upon hypotenuse. It is the ratio of perpendicular and hypotenuse. Then you have got cos theta, it is base upon hypotenuse, and then we have got tan theta, it is perpendicular upon base. These are the 3 main trigonometric ratios. Also we can call them as trigonometric functions. Now you are understanding why they are trigonometric functions. Everyone remembers sine 45 degrees 1 by root 2, sine 60 degrees root 3 by 2, sine 90 degrees 1, sine 30 degrees 1 by 2. What you are trying to do? You are putting input values and you are getting output. So it's like a small machine. It's like a small machine. Right? So trigonometric ratios can be also called as trigonometric functions. That means sine theta, cos theta, tan theta and their reciprocals, which are, for sine theta we can write down cosec theta, which is hypotenuse upon perpendicular. For cos theta we can write down sec theta, which is hypotenuse upon base. And for tan theta we can write down cot theta, which is base upon perpendicular. Got it? Now, simple things, my dear friends. If you are going to look here and here, please note one thing. One thing is for sure, that hypotenuse is always greater than perpendicular and hypotenuse is always greater than base also. As we all know, I have mentioned this point, hypotenuse is the longest line, sorry. So if hypotenuse is longest, that means this P upon H will never be greater than 1. It will never be greater than, this one will also be never greater than 1. Whereas we don't have any restriction for tan theta. So at this point only, I am going to tell you that sine theta will always have maximum value as 1. It will always have maximum value as 1. But we are going to come to this point later, when we are going to talk about range of sine theta and cos theta and tan theta. Over there we are going to talk about it. But right now everyone can see that absolutely, because hypotenuse is the longest side, this ratio, this output will never be greater than 1, will be always less than 1. Now what is the minimum value? We are going to talk about it. Got it? So now the thing is, my dear friends, let's talk about this. Let's suppose we want to find out 6 trigonometric ratios, right? So if, let's say, we have got like, this is theta, this means that this is perpendicular, this is perpendicular. This is theta, this means that this is base. This is theta, and we don't have any doubt in hypotenuse. So sine theta will be perpendicular upon hypotenuse. Cos theta will be base upon hypotenuse. Tan theta will be perpendicular upon base. And then cosec, sec, cot, all of those things. Right? Clear? Done? Any doubt? Come on. Let's say I am saying sine theta is, and I mean you guys can write for sec, cosec, cot, I am not writing it. Let's suppose I am saying given sine theta is 3 by 5. Sine theta is 3 by 5. Given that sine theta is 3 by 5, find out base. Find out base. This is theta, find out base. Find what base is. Find what base is. Come on. Sine theta is 3 by 5. Over here, sine theta was 4 by 5. Right now sine theta is 3 by 5. What is base? Sine theta is 3 by 5. What is base? Base can be anything. This is what I was trying to say. This is a very common thing, not a very big thing. Okay, you all are saying correct. You all are correct, but yes, answer is it can be anything to a multiple, which will give me. Let me tell you something. Please see. See, we are talking about this triangle. Now you are saying, sir, if this is 3, this is 5, then this is going to be 4. But my point is, dosto, if someone says, please understand, if someone says sine theta is 3 by 5, if someone says sine theta is 3 by 5, it doesn't mean that we always have to draw a triangle and make 3 and 5 as sides. Although it is absolutely correct that if it is 3 by 5, this is absolutely correct that if this is 3 by 5, this will imply that cos theta will come out to be 4 by 5. And tan theta will come out to be 4 by 3. Tan theta will be come out to be, my bad, 3 by 4. This is always true. This is always true. Always true. But my point is, we cannot only assume that there is only one triangle. There can be more triangles. Let me explain this concept. There can be more triangles. For example, let's suppose sine theta is 3 by 5. Now, this is the simplest ratio. We cannot cancel 3 and 5 any further. But what if actually the number is 3 times 2 and actually the number is, my bad, this is 2. So this is 10. What if we have got a triangle? What if we have got a triangle which is just double of this size? Which is just double of this size? Please try to understand. Are you able to relate with this concept? That means, let's say this is 6 and this is 8. My bad. This is 6 and this is 10. Still, when you are going to cancel it, it will come out to be 3 by 5. But now, obviously, base will be different. Obviously, now base will be different. That's what I'm trying to say, that this is always true. This is always true, but we are not going to say that base will be only 4. Right? We can't say that. Hopefully, it is clear to you. Now, you can find out the value of base from Pythagoras over here, or you can simply write 4 times x. So when you are going to write 100 minus 36 and root of it, right, and this is going to be 64. 64 root is 8. That means 4 times of 2. This is 4 times of 2. A very simple thing. If you are going to write down this in the chat box, I'm going to move on. Clear? Done? Na? Absolutely fine. Done. So in this problem, they have given us a triangle. They have given us a triangle, and that's why we wrote ratios like this. But when you have got a ratio of sine theta, you can find other ratios. You can find other ratios. But when we are going to talk about triangle, please note there can be many more triangles possible, infinitely more triangles possible. Done? Clear? All right. Moving on. Now, 4 quadrant and ASTC rule. 4 quadrant and ASTC rule. For this, my dear friends, what we need to do is, let's suppose this is x-axis, this is y-axis, pay attention, this is positive x-axis, this is positive y-axis, this is negative x-axis, this is negative y-axis. Let's make a circle over here. let's make a circle over here. All right, clear? And let's suppose we have got 4 points. We have got 4 points. One point is somewhere over here. Right? One point is somewhere over here. Another point is at this point, and another point is at this point. Clear? And we want to make right angle triangle, something like this. Let's join this point. Let's join this point, something like this, and let's drop a perpendicular from here, right? Because I'm calling it perpendicular because I'm going to call this angle as theta. This angle as theta. Pay attention. This angle as theta. All right. Let's suppose this coordinates are x comma y. Now my point is, in the first quadrant both x and y are positive. In the first quadrant both x and y are positive. That means in the first quadrant, when we are going to talk about first quadrant, when you are going to talk about first quadrant basically means from 0 degree to 90 degree. From 0 degree to 90 degree or 0 radian to pi by 2 radian. From 0 radian to pi by 2 radian. Now in this quadrant, if you are going to write down sine theta, we will get perpendicular. This is perpendicular y, this is base, and hypotenuse is, let's suppose hypotenuse is r. Hypotenuse is r, that means length of that line. Length of that line is always positive. So this is a note that r is always positive because this is length of line. R is always positive. So that means sine theta will be perpendicular upon r. Now my point is r is positive. R is positive and y is also positive. That means sine theta is positive. Sine theta is positive. And if you are going to pay attention, cos theta will be base upon hypotenuse. That means x upon r. This will be also positive because x is also positive, r is positive. Tan theta will also be positive. This will be perpendicular upon x. This will be also positive. If sine theta, cos theta, tan theta are positive, their reciprocals will also be positive. In short, my dear friends, we are going to say that all trigonometric ratios are positive in first quadrant. All are positive. All trigonometric ratios are positive. That is what this A stands for. All are positive in the first quadrant from 0 degree to 90 degree. That's why whenever you learn the standard angles, we never come across any negative value. Let's say tan 30, sine 60, cos 30, cos 45, cosec 60, sec 20, any angle in 0 degree to 90 degree, every trigonometric function will give positive output. Positive or 0. Positive or 0. 0 is not considered in positive, right? So you can call it as non-negative. They all will give only non-negative values if from 0 degree to 90 degree or in first quadrant. Concept is in front of you. Now let's talk about second quadrant. I have made a copy of this. I am simply removing this thing. Second quadrant. That means now the angle is from 90 degree to 180 degree or 90 degree, that is pi by 2 to pi degree. Let's say this is a point. And we are going to make, now we are going to make triangle like this. And see why we are talking about angle. We are talking about angle something like this. From x axis in the anti-clockwise direction. This is our angle. Alright. This is our angle. This is our new angle. Now we are discussing about this theta. Got it? Now we are discussing about this theta. But if we want to make a right angle triangle, I will make a right angle triangle something like this. I will make a right angle triangle something like this. And I'm going to call this as another angle. I'll call this as sine alpha. I'll call this angle as alpha, not sine alpha. I'm going to simply call this as alpha. Now pay attention. My dear friends, when we are going to discuss sine, when we are going to talk about sine in the second quadrant, pay attention. Sine will basically give me this, the coordinate of this point is going to be minus of x comma y. Y-axis is positive, x-axis is negative. So sine is perpendicular upon hypotenuse. Perpendicular is y, hypotenuse is r. This is positive. When you are going to talk about cos in the second quadrant, cos is base upon hypotenuse. Base is minus x, r is positive. Negative divided by positive, answer will be negative. When you are going to talk about tan, tan will be perpendicular upon base. Perpendicular is y, base is minus x, that means negative. It means that in the second quadrant only sine is positive. In the second quadrant only sine is positive. Similarly, in the third quadrant only tan is going to be positive. And in the fourth quadrant only cos is going to be positive. So now you can remember a small phrase, that is, you can, add sugar to coffee, whatever you want to do. You can simply remember after school to college, है ना? After school to college. So from pi by 2 to pi only sine is positive. From pi to 3 pi by 2, my dear friends, this angle is 3 pi by 2 or 270 degree. 270 degree. And this is again what? Yeah. And that is again 360 degree. This is very, very important. All silver teacups. Now, I think best is after school to college or add sugar to coffee. That's it. Right? That's it. If tan is positive, then cot is also positive. If cos is positive, then sec is also positive. If sine is positive, then cosec is also positive. We don't have to worry about that. But it is very important for you to remember these things. We are going to use it extensively. Now I am not writing it for third and fourth quadrant. You guys can do it by yourself. Moving on, right? Moving on, my dear friends. These are some of the standard values. These are some of the standard values. Let me first help you to understand this. See what we are trying to do. I've got a special method, I've got a special analogy to explain this. See, let's suppose this is some reference line and this is our hypotenuse. This is our hypotenuse. What I'm trying to say is that only hypotenuse is the reality for us. Please hear me out very carefully. This will also help you to understand resolution of vectors. Got it? This will also help you to understand resolution of vectors. Dosto, the only reality is hypotenuse, right? Only reality is hypotenuse. This is hypotenuse. Hypotenuse can be considered as length of a rod, length of a line. This is the reality. Now, perpendicular and base are nothing because it depends upon theta. If you are going to change theta, perpendicular and base are going to change. This is theta that I am talking about. This is theta that I am talking about. Let's suppose we are making a copy of this, and over here, my dear friends, I am saying let's try to decrease this theta. So if you want to decrease this theta, see what we can do. We can do something like this. See, theta is decreasing, isn't it? Theta is decreasing. What we are seeing over here is as theta is decreasing, perpendicular is also decreasing. This is what perpendicular is. This is what perpendicular is. According to theta, this is what base is. This is base, this is perpendicular, this is hypotenuse. I have said that the only reality is hypotenuse. Perpendicular and base depends upon theta. So if I'm going to change theta, perpendicular is decreasing. Perpendicular is decreasing. What will happen if I equate theta as 0 degree or 0 radian? What will happen if theta is 0 degree? If theta is 0 degree, this will look something like this. Isn't it? Theta will, my bad, if theta is 0 degree, then situation is going to be something like this. Perpendicular has vanished. Perpendicular has vanished, and we can see that hypotenuse is all equals to base. Hypotenuse is all equals to base. That means when you are going to write down cos 0 degree, when you are going to write down cos 0 degree, you are going to write base upon hypotenuse. In this specific case, base and hypotenuse are same. That means cos 0 degree will become 1. When you are going to write down sin 0 degree is perpendicular upon hypotenuse. No. Sin 0 degree is not only perpendicular upon hypotenuse. Any sine theta is perpendicular upon hypotenuse. So is sin 0 degree also. So sin 0 degree will be perpendicular upon hypotenuse. We all can see that perpendicular is now 0 in this specific case. That means sin 0 degree will be 0. And so on. Let's suppose now we have got another case in which we are saying this is hypotenuse. This is hypotenuse. That means now the angle is 90 degree. Now the angle is 90 degree. As you are going to increase this angle, base will decrease. As you are going to increase the angle, base will decrease and perpendicular will increase. That's what happens in sine, cos and tan table, right? And now you can remember it. Obviously, I hope 90% of these things are you already know. Clear? Done? So this is radian, 30 degree, 1 by 2, 37 degree. Kindly remember these two specific values, that is 37 degree and 53 degree if you don't remember it yet, right? 37 degrees 3 by 5, 53 degrees 4 by 5. One small thing that we can write when we were discussing sine theta, cos theta and tan theta, that is tan theta can be also written as sine theta upon cos theta. Right? Sine theta upon cos theta. We can write this as well. So this table is all good, I believe. At least remember till 90 degree. After 90 degree, I am going to help you how to find out these values. Leave that to me. We are going to talk about that. Clear? Done? So I have given you an idea why sine 0 is 0. Why sine 0 is 0, why cos 0 is 1, why sine 90 will be 1 and why cos 90 will be 0, right? Now let's move on. Now let's talk about certain trigonometric identities which are very, very important. These three are the very basic identities that you have done in your class 10th. Sine square theta cos square theta equals to 1. This is nothing but simple Pythagoras theorem. Sine theta is, friends, sine theta is perpendicular upon hypotenuse. Cos theta is base upon hypotenuse. I am only talking about LHS right now. So this will become perpendicular plus base square will become h square divided by h square, that will come out to be 1. So this is very simple. This is nothing but an extension to Pythagoras theorem. Now in the first equation, sine square theta plus cos square theta is equals to 1. In this equation, if we are going to divide everything with cos square and cos square, this is absolutely valid in maths. We do it all the time. This will become 1. This will become sec square, sine upon cos will become tan. So tan plus 1 is equals to sec square. Similarly, in this equation, if we are going to divide it by sine, this will become 1. Cos upon sine will become cot. 1 upon sine is cosec. 1 upon sine square will become cosec square. Clear? So hopefully these three are all done and dusted. After this, my dear friends, I want you to remember these two identities. These are very, very important, right? These are extremely important. Whenever you are going to forget anything, my dear friends, we are going to come back to these two things, right? So these are going to be our north pole star for finding any other identity. This is very simple. Sine of A plus minus B, sine A cos B plus minus cos A sine B. Cos of A plus minus B is cos A cos B minus plus sine A sine B. Let me give you one example. Let's suppose we want to know sine 15 degree. Now sine 15 degree can be written as sine 45 degree minus 30 degree. 15 degree is unknown, but we can rewrite 15 as 45 minus 30, and we can use the first identity, that is sine A cos B. If we have got a minus over here, we will have a minus over here as well. Minus cos A sine B, right? So we will get 1 by root 2 multiplied by root 3 by 2 minus 1 by root 2 multiplied by 1 by 2. And now whatever this value is, I don't want to find out value right now. The point is that we can use these identities wherever we want, right? So sine of A plus minus B can be written something like that. Similarly, cos of A plus minus B can be written something like this. Now another use of this identity. Another use, my dear friends. Let's suppose we want to write down sine 2 theta. So sine 2 theta can be written as sine of theta plus theta. That means sine theta cos theta. If we have got plus, then plus over here, and then cos theta and sine theta. So this is nothing but 2 sine theta cos theta. Right? This is nothing but 2 sine theta cos theta. Let me know if you have any doubt in this, my dear friends. Be quick. Clear? Friends, all done and dusted? Very, very important, sine 2 theta. Now cos 2 theta. Again, extremely important identity. Cos 2 theta can be written as, again, we are going to remember it, but let me explain it to you. It can be written as cos theta plus theta. That means cos A cos B, cos A cos B. If we have got minus over here, then we are going to write the opposite of it. That means if plus, then minus. Sin A sin B. Sin A sin B. This is our, this is our very, very important identity. Note it down. Note it down here. Note it down here. We are going to use it in almost every chapter, somewhere or the other, in some numerical or in some derivation. We are going to use it, right? So now cos 2 theta can be written as cos square theta minus sin square theta. Now what's so important about this identity? Let me tell you. See, it is a perfect identity. It is a perfect identity to convert double angle into a single angle, right? So this is double angle 2 theta. This is simply theta. So what also we can use it in different ways like this. Let's say cos 2 theta can be written as, my dear friends, cos square theta. I'm going to write it over here. Cos square theta can be written as 1 minus sin square theta. Done. So cos 2 theta, we are going to use this small thing. Hopefully this is visible to you. Cos 2 theta can be written as 1 minus 2 sin square theta. Further, you can rewrite this thing as sin square theta is equals to 1 minus cos 2 theta divided by 2. We are going to use this in integration because we don't have any product rule in integration. So we cannot find out integration of sine square theta, but we can find out integration of 1 upon 2. We can also find out integration of cos 2 theta, right? So this is very important. Remember this. At least if you can't remember this, then please remember this formula. And every time you want to convert 2 theta into cos square theta or sine square theta into 2 theta, you can use this. Another use, my dear friends, we can rewrite cos 2 theta. We can similarly, we can also say that sine square theta can be written as 1 minus cos square theta. 1 minus cos square theta. That means cos 2 theta will be written as, friends, 2 cos square theta minus 1, or cos square theta will be written as 1 plus cos 2 theta divided by 2. 1 plus cos 2 theta divided by 2. So sine square theta 1 minus cos 2 theta divided by 2. Cos square theta can be also written as 1 plus cos 2 theta divided by 2. This is very, very easy. Please see, let's say we want to rewrite sine square theta by 2. So sine square theta by 2 can be written as 1 minus cos theta divided by 2. Is it clear? 1 minus cos theta divided by 2. Let me know, friends, if you have any doubt. Similarly over here as well, right? So if let's suppose instead of theta we have got theta by 2, so instead of 2 theta we can write down theta. Done? I mean, hopefully you guys remember, we have used all these things many times in physics, here and there, in different derivations, numericals. So all of these 7 identities are very, very important. Very important. If you haven't remembered these yet, I will request you to go through them after every 2 days. Got it? Very important. Now these are slightly less important. But again, for you, when someone says slightly less important, that is where you can take a lead, because maximum students are going to ignore that. So if you want to leave no stone unturned, please remember these as well. But surely we are not going to extensively use these 4 identities. We are not going to extensively use these 4 identities. Again, these 2 identities you already know from class 10th. That is tan of a plus minus b and tan 2 theta. So it requires no further explanation. I believe I can move on. Right? I can move on. Now the most important topic for today's class. That is trigonometric reduction formulas. Let's suppose someone tells you to find out the value of sine 720 degree. Or let's suppose someone tells you to find out the value of sine 750 degree. How to do these kinds of things, right? We are going to learn this right now. So the first point to remember is that trigonometric functions of an angle 2n pi plus theta. This is the most important thing. 2n pi plus theta basically means if n is equals to 0, that means theta. If n is equals to 1, that means 2 pi plus theta. Let me explain it to you. Let's suppose this is x-axis, this is y-axis. This is the line that we are talking about. This is the angle theta. Right? Clear? Now 2n pi plus theta. That means if let's suppose n is equals to 0, that means we are talking about this angle only. Now let's say n is equals to 1. If n is equals to 1, that means 2 times of 1, that is 2 pi plus theta. So what is 2 pi plus theta? It means that from this point, dosto, from this point, let's move an angle of 360 degree. So if we are going to move an angle of 360 degree, we'll reach back to the same point. We'll reach back to the same point. Got it? Right? So if you are going to reach to the same point after 2 pi, that means every other trigonometric ratios, for example, a sine of 2 pi plus theta will be sine theta only, because you are reaching to the same exact line as before. Similarly, cos of 2 pi plus theta will be also cos theta. There is no difference. There is no difference, because it's nothing but we are coming back to the same point. We are coming back to the same point like this. From this point you are moving, and you have moved complete circle, and you have come back to the same point, right? 360 degree. Let's suppose, and this is true for any function, tan also, 2 pi plus theta, again tan theta. Now let's say we are talking about n equals to 2. So for n equals to 2, it will become 4 pi plus theta. That means this was 360 degree, this is 720 degree. This means that now we are talking about one circle, another circle. Again we are reaching back to the same point. If you are going to move 10 circles, again you will reach back to the same point. That's why instead of talking about 1, 2 and 3, we are going to now simply say that if you have got sine of 2n pi plus theta plus minus theta, we will get sine theta only. We will get sine theta only. Similarly, cos of 2n pi plus minus theta, you will get cos theta only. Same for tan as well. We have got everything written over here, I believe. You find clear? Hopefully, no doubt, my dear friends. Next. So just for example, let's say we have got sine 390 degree. Find out the value of sine 390 degree. Cos 420 degree. Tan 540 degree. 550 degree. Find out the values. Quick. Be quick. Find out the values. Sine 390 degree. Sine 390 degree can be written as sine 360 degree. Sine 360 degree plus 30 degree. That means this, it can be written as simply sine 30 degree. That means 1 by 2. Sine 420, cos 420 degree can be written as cos of 360 degree plus 60 degree. That means cos of 60 degree. This will come out to be again 1 by 2, right? Tan of 550 degree. Now pay attention. For this one, let me change it for a moment. Let me write it as not 550, because for 550 we will have to use another reduction formulas that I have not yet explained. So we are going to talk about tan 550 later on. Right now let's write it as 450 degree. I wanted to write 450 degree. That means sine 360 degree plus 90 degree. Tan. This will become tan 90 degree, which is not defined. Here 450, not 550, 450. Next. Pay attention, extremely important. That's clear till here, right? Now they are saying if the angle is in the form of n pi by 2 plus theta, n pi by 2 plus theta, and n is even, then the trigonometric function will remain same, and sign of trigonometric function will be according to the value of that function in the quadrant. Let me explain. Let's suppose they are talking about n pi by 2 divided by theta, right? And they are saying if n is even, let's take an example of even. The easiest example n is equals to 2. N is equals to 2. That means pi plus theta. If n is equals to 2, this means that 2 pi divided by 2 plus theta, right? 2 pi divided by 2 plus theta. So they are saying trigonometric function will remain same. So that means sine of pi plus theta will be sine theta only. Now come back for direction. Quickly draw x axis and y axis. Quickly draw x axis and y axis. Friends, this is 0 degree, this is 90 degree, this is 180 degree, this is 270 degree. Pi plus theta means 180 degree some angle, and this theta is always acute, right? This theta is always acute. So that means 180 degree is this angle. 180 degree is this angle. That means our angle, our line is somewhere over here. This is what we are talking about. This is pi plus theta. Pi plus theta means third quadrant. Pi plus theta means third quadrant. Third quadrant means in third quadrant only tan is positive. This means that this is going to be negative. This is going to be minus sine theta. Let's take an example inside of an example. Let's suppose we are talking about sine of 180 degree plus 60 degree. That's going to be sine of, dosto, this is going to be 240 degree, and answer should be minus times of sine 60 degree, that is minus root 3 by 2. This is what it does. It helps us to quickly find the answer. Sine 240 degree can be written as pi plus theta. If we have got pi over here, that means n is equals to even. If n is even, then sine will remain sine. Same trigonometric function. And positive or negative will be decided with the help of quadrant. Positive or negative will be decided with the help of quadrant. That means this is going to be minus sine 60. Now let's see how this is going to work. We can solve this using sine A cos B plus cos A sin B. I'm so sorry. Cos A sin B. Friends, sin 180 degree is 0. Cos 180 degree is minus 1. Minus times of sin 60 minus sin 60 root 3 by 2. Clear? Done. Let's talk about more such examples. Don't worry. Let's say we are talking about sine of 210 degree. Let's suppose we are talking about sine of 150 degree. Sine of 150 degree can be written as sine of 180 degree minus 30 degree. My point is whenever you are going to see this 180 degree, you can rewrite it as 2 pi divided by 2. And we are going to look for this 2. That means this is even. If this is even, we are going to quickly write it as sine 30. And now we are going to look for this quadrant. 150 degrees in second quadrant. Sine is positive. So plus sign. Quickly let me know in the chat box. Right? 180 degree means 2 pi by 2. 2 means even. Even means sine will remain sine. Even means that function will remain same. That function will remain same. Now let's try to prove this using another thing. If we are going to expand it using sine A B formula. So sine A cos B minus cos A sine B. Sine 180 degrees 0, cos 180 degrees minus 1, minus plus, sine 30 plus sine 30. So you can quickly find out the answer, right? Let's take another example, sine 210. Dosto, again sine 210 can be written as sine 2 pi by 2 plus 30 degree. Please don't mind, I'm writing in radian, half I'm writing in degree. I just want you to understand what do we mean by this. If n is even, then trigonometric function remains same. If this n is even, what do you mean by even? Even basically means that n can be 2, 4 or 6. Mainly we are going to use 2. Right? Clear? So this is going to be, by the way, this is in third quadrant. So sine will remain sine with a negative sign, because third quadrant, answer is going to be minus 1 by 2. Another example, my dear friends, pay attention. Now you do this. Cos of 120 degree. Dosto, cos of 120 degree can be written as cos of 180 degree minus 60. 180 degree means even. 180 degree means even. Even means cos will remain cos. Now 120 degree is in first quadrant. In first quadrant only sine theta is positive, cos is negative. So minus. Answer is minus 1 by 2. Pay attention. Pay close attention, dosto. Done? Clear? Clear? Any other? Cos of 240, cos 240 is done kya? I don't think so. Let's write cos 240. Find out cos 240. Find out cos 240. Be quick. Find out cos 240. Be quick. Cos of 240. Cos 240 can be written as cos of 180 degree plus 60. 180 degree means n is even. Again and again I am saying 180 degree means n is even. So this will become cos of 60. By the way, 240 is in third quadrant. 240 is in third quadrant. 240 is in third quadrant. Third quadrant basically means tan is only positive. Therefore, This is going to be minus. That means again minus 1 by 2. Again minus 1 by 2. Again minus 1 by 2, friends. Is it clear? Cos of 150 degree. Cos 150 degree. Cos of 150 degree. Quickly. First of all, first quadrant. First quadrant. It can be written as cos of 180 degree minus 30 degree. This will, because it is even, cos will remain cos, that is 30 degree. Yeah, why I am writing first quadrant, second quadrant. Did I write somewhere else also first quadrant for this thing? No, right? Everything else is correct, right? Second quadrant, yeah. For this, we have got second quadrant. So this is second quadrant, only sign is positive. So this is going to be minus root 3 by 2. Minus root 3 by 2. Here, second quadrant. Absolutely. Any problem, any doubt, my dear friends? Kindly see this. If you have any doubt in any of these things, let me know. See, we are saying if n is even. Kindly note, if n is even. If n is even, sign of trigonometric function will be according to that function in quadrant. Right? So sine of pi minus theta will be sine theta because it is first quadrant. My dear friends, pi minus theta is first quadrant, that is plus sine theta. Cos of pi minus theta is minus cos theta because again, yeah, sorry. This is second quadrant, sine is positive. Second quadrant, cos is negative. Second quadrant, tan is negative. Third quadrant, sine is negative. Third quadrant, cos is negative. Third quadrant, tan is positive. 2 pi minus theta, fourth quadrant, 2 pi minus theta, sine is negative. This is fourth quadrant. So if someone tells you, now let's come back. Let's say this is x-axis. This is y-axis. And someone says we have got an angle of minus 30 degree. Minus 30 degree. Right? Well, you can also rewrite this angle as in this form 2 pi minus 30 degree. 360 degree minus 30 degree. That is 330 degree. Is it clear? So either you can write it as 330 degree or minus 30 degree. So if someone is going to write it as 330 degree, that means 2 pi minus, it will become minus sine theta. Cos will become positive because remember cos is positive in the fourth quadrant, tan will be also negative. Hopefully this is all clear. Done? Any doubt? Sorted, my dear friends. Last, second last. And this is also very simple. Now, if let's suppose n is odd, if n is odd, that means n is equals to 1, 3, 5 and so on. If n is odd, then what will happen? Then the function will get converted into its complementary function. Complementary function. Let's first understand this concept. The function will get converted into its complementary function. Right? The complementary function of sine theta is cos theta. We'll discuss this, why we are calling it as complementary function. Right? Alright. The complementary function of tan theta is cot theta. Remember this concept. So if it is odd, it will be converted into its complementary function. Example, let's say you have got sine and n is odd. That means pi by 2 plus theta. So n is equals to 1 odd. So sine will be converted into its complementary function. And my dear friends, pi by 2 plus theta. Pi by 2 plus theta is second quadrant. In second quadrant, sine is positive. We don't have to look for cos. Now, we have to look for sine. Sine is positive, so we are going to put up a plus sign. And why for sine? Cos is only the complementary function, because even if when you are going to rewrite it, for example, as sine A cos B plus cos A sine B. Cos pi by 2 is 0, sine pi by 2 is 1, 1 times cos theta is cos theta, 0 times anything is 0, that means your answer is going to be cos theta. So this is why they are complementary functions, right? So sine of pi by 2 plus theta is cos theta. Let me give you another example. Let's suppose we are writing sine of 3 pi by 2 plus theta. After n equals to 1, another odd number is 3. Got it? Another odd number is 3. So 3 pi by 2 plus theta, 3 pi by 2 means 270 degree. So if you have got 3 pi by 2 plus theta, if n is odd, sine will be converted into its complementary function. And 3 pi by 2 plus theta is fourth quadrant. And in fourth quadrant, sine theta is negative. So answer is going to be minus cos theta. Answer is going to be minus cos theta. Right? Kindly solve this. Now let's suppose we are writing sine 120 degree. But let's not write 120 degree as 180 minus 60. Now let's write it as sine of 90 degree plus 30. So we are going to simply write it as cos 30 or root 3 by 2. Or if you remember, earlier we used to write it as sine of 180 degree minus 60, and when it is even, then it will not change. So it will remain sine 60 degree. Is it clear, my dear friends? Hopefully everything is sorted. Let's write sine 300 degree using this rule. Come on, be quick. Sine 300 degree. Hi, yaar, sorry, yaar. I don't know why I am always talking about first quadrant. It is second quadrant. Okay, it is second quadrant. Done. Come on. Sine 300 degree. So now we are going to rewrite it as sine 270 degree plus 30 degree. This is odd. 3 pi by 2. Kindly remember, this is odd. 3 pi by 2. 3 pi by 2. So 270 degree plus 30 degree. That means this will become, sine will get converted into its complementary function. And this is fourth quadrant. This is fourth quad. In fourth quad, sine is negative. So answer is going to be minus root 3 by 2. Or if you want to rewrite it, this thing can be written as sine of 360 degree minus 60 degree. Because 360 degree is even, we are going to simply write it as sine 60 degree. And again negative sign and minus root 3 by 2. It's up to you what you want to use. Is it clear? Done? Students will carry a type of aura in school as well as in NEET exam center. Because of me, then that's really good. But aura should help. All done and dusted? Clear? Let's find out values for these things. I mean, most of them we have already done. Just one more thing, just one more thing, then we'll move. Remember these as well. Sine of minus theta is minus sine theta, cos of minus theta is cos theta, and tan of minus theta is minus tan theta. You can simply remember it for cos. You can simply remember it for cos. Cos of minus theta is cos theta. If you remember, just now we were talking about it over here. See, this 2 pi minus theta can be written as, this thing can be also written as either sine of 330 or sine of minus 30 are same, and value will also be same, that's going to be minus sine 30 degree. But for cos it is different. See, for cos 330 or cos minus 30, both will give same answer, that is plus cos 30. And again for tan it is minus. So simply remember it for cos, that cos will eat that minus sign. Cos is going to eat that minus sign, remember this, right? All the other trigonometric functions will give out minus sign like this, minus of sine theta and minus of tan theta. Clear? Done? Find the values of these things. I think cos 120 is done. Tan of minus 60 will be, minus tan 60. That means minus root 3. Tan of 330 degree, doston, let's do it like this. Tan of 270 degree plus 60 degree. That means this is odd. Tan will get converted into cot. So cot 60 degree. This is fourth quadrant. That means minus sign. That means again answer is going to be minus root minus 1 upon root 3. Isn't it? Minus 1 upon root 3. Or you can use different method. Instead of this, if you want to rewrite it as tan of 360 degree, which is even, minus 30 degree, then we won't have to change it. We'll simply write it as tan 30 degree, but sign for plus or minus 330 degree is in fourth quadrant. Fourth quadrant only cos is positive. That means answer is going to be minus 1 by root 3. See, I have explained everything to you. Now it's up to you, your practice. You can solve any question. Is it clear? You tell me what we need to find out. I'll do it for you, right? Let me give you some more problems. Cos of minus 60 is simply cos 60. That is 1 by 2. Cos of minus 20 is simply cos of 120, which is minus 1 by 2. Cos of minus inside cos has no meaning. You can simply remove it, right? You can simply remove it. Sine of 150 degree is going to be minus of sine 150 degree. Now 150 degree can be written as sine of 180 degree minus 30 degree. Now this is second quadrant. That means this answer is going to be minus sine 30 degree. That means minus 1 by 2. Minus 1 by 2. Is it clear? All cool? Let's suppose someone tells you let's say sine of 19 pi by 3. Sine of 19 pi by 3. Something like this. Sine of 19 pi by 3. Right? Now let's see how to solve these types of problems. What you need to do over here is divide this 19 and 3. Divide this 19 and 3. Huh? So that means this will become 19 and this will become 3. This will become 6, 18 and 1. 1 is the remainder. Got it? 1 is the remainder. That means, my dear friends, you can rewrite 19 pi by 3 as 6 pi plus pi by 3. 6 pi plus pi by 3. Is it clear? Got it? What I have done? If you are going to solve it, this will become multiplied by 3 multiplied by 3. 3 6 are 18. 18 pi plus 1 pi is 19 pi. 19 pi divided by 3. That means this 19 pi by 3 can be written as sine of 6 pi plus pi by 3. 6 pi plus pi by 3. Any doubt in this? And 6 pi is nothing but 3 times of 2 pi. So this is going to be simply sine of pi by 3, which is sine 60 degree, which is root 3 by 2. All right. Done. Sine 19 pi by 3. Like this, you can find any other value. All right. All you need to do is you need to divide it and find out. Let's say this is 6 pi. Now, if you have got problems, or how did you know this is pi by 3? So you can do one thing. You can write down 19 pi by 3 minus 6 pi. If you are going to do it, you will get pi by 3. That is your remainder, right? Also, you can see remainder is 1 over here. Now, hopefully everything is clear till this point. Done. Now, friends, if you have any other doubt in this table, let me know. Else, I've got one more table for you, which you can do for homework and you can remember this. I mean, there is not a single point which we have missed. You can cherry pick any one, right? Let's take an example of this one. Cos of, I'm picking any random one and then few I'll leave it to you. Cos of 270 degree. Dosto, 270 degree means odd. 270 degree means odd. That means cos will change into sine. 270 degree plus theta is fourth quadrant. That means cos is positive. That means positive sign. Now let's cherry pick anything. Let's take this one. Tan of 180 degree minus theta. 180 is even. 180 is 2 pi by 2. Even, that means tan will remain tan. 180 minus theta, that means second quadrant. Sine positive, that means minus tan theta. Any 360 degree minus theta. 360 degree is even. Sine will remain sine. 360 degree minus theta, fourth quadrant. Fourth quadrant, cos negative, only cos positive. Sine negative, minus sine over there. Is it clear? Any doubt? This one, 180 degree even, cos remains cos. 180 degree plus theta, third quadrant, tan positive, minus sign. And we are going to look for this function for sine, not for this. We are going to look for this function for sine. Let's take some odd. Tan 270 degree minus theta, 270 degree odd. Tan will be converted into cot. 270 degree minus theta is third quadrant. 270 degrees boundary. Now you are subtracting theta. That means you fall into third quadrant. Third quadrant basically means tan is positive. That's why plus cot theta. Clear? So this is this table is for you. Play with it. Play with this, right? Minus sine theta minus cos minus theta. Cos will eat minus sine. Only cos eats. Tan minus tan. Done and dusted. Now let's talk about range of trigonometric function. Come on, how many of you are still here? Let me know, and from which batch you are from. Let's talk for 2 minutes. Quick. Let's talk for 2 minutes. Let me know. Be quick. Suhas, Arun. Hi Suhas, I remember you, buddy. Acha, by the way, today you got one class, na? Sir, is this class basics are in? Are haan, this is more than enough here. This is more than enough. No, you can always watch that recording, Sakshi, which is available in your Yakeen NEET English batch. You can always watch that. Most of you are from Yakeen batch, huh? Duration is, we'll stretch it at least till 12. We'll stretch it at least till 12. Okay, Aruna. Okay, Alfia Ansari, all from Satya. Okay, hi Satya. Purva, Yakeen, Harish, Laksh. All right, less students are from Lakshan today. Yakeen, Teja, Omali. All right. Everything's cool till this point. I know your name, na? That's how I remember. I've got a decent memory. Sir, aren't you tired? No, not yet. Sir, will we practice any problems? Yeah, I mean, we are getting prepared for solving problems, right? All of these, first we are going to learn these tools, then we'll be able to solve problems. Sec also it, sec also it, correct. All right, shall we start then? Range of trigonometric functions. Friends, as far as sine theta is concerned, range of sine theta is range of sine theta is from -1 to +1. From -1 to +1, right? That's why when we are going to talk about the graphs of sine theta, graph will be between y equals to 1 and y equals to +1 and y equals to -1. +1 and -1, and graph is actually somewhat like this, right? Done. Sir, me, Sainiba. All right, hi everyone, hi. Right, so range of sine theta is this, from -1 to +1. Range of cos theta is also same. Range of cos theta is also same, that is from -1 to +1. Last, range of tan theta. Range of tan theta is from -infinity to +infinity. All real number. Tan theta gives all real numbers. And now you can relate this, that tan theta is actually perpendicular upon base. So perpendicular and base can have any output. This ratio can have any output, dosto, right? This ratio can have any output, but obviously for cos theta, when we are talking about base upon hypotenuse, hypotenuse can never be less than base. At max, they can become equal. And if you are going to add a negative sign, that means -1. So -1 to +1. Same with sine theta. Sine theta is perpendicular upon hypotenuse. But for tan theta, we don't have any such problem. So range is going to be from -infinity to +infinity. You are also from Yakeen batch. Good, good, good. Done. So this is also all clear. Now, my dear friends, a very small topic, that is small angle approximation, but again let me tell you, we are going to use it a lot, right? First of all, understand what do we mean by small angle. If theta is less than 10 degree. If theta is less than 10 degree, then angle is considered as small. Then angle is small, right? So the first approximation is sine theta. This is true only when theta is small. Sine theta can be written as theta, but here the most important point is that this theta is in radian. This theta is in radian, my dear friends, right? This theta is in radian. For cos theta, if theta is very small, you can rewrite it as simply 0. You can rewrite it as 0. There is also a second order approximation for cos theta, which is, this is first order approximation. Second order approximation is cos theta can be written as 1 minus theta square by 2. This is second order. This is slightly less used, maybe once or twice you are going to use this second order. Most likely we are going to use this. Also, one very important point, that if angles are small, then sine theta can be written as tan theta, and they both can be simply written as theta. They both can be written as theta. This is also important. That's it. Trigonometry, this much trigonometry is more than sufficient for your 2 years of physics. Let's take some examples. Sine 1 degree. What is going to be the value of sine 1 degree? Quickly in the chat box, answer. Sine 1 degree. Be quick. What is going to be the value of sine 1 degree? What is going to be the value of sine 1 degree? 1. What is going to be the value of sine 1 degree? And tan 2 degree and cos 1 degree. Cos 1 degree is going to be 0. No doubt about it. What is sine 1 degree? Good, very good. First of all, no, very good. All are wrong. You all are wrong. Not a single answer is correct. So tan 2 degree, what is sine 2 degree? Acha, fine. With this logic, kindly tell me what is sine 5 degree. What is sine 5 degree? What is sine 5 degree? So you are going to say sine 5 degree is 5. What is sine 5 degree? What is sine 5 degree? My dear friends, the first thing is to convert this 5 degree into radian, that is 5 multiplied by pi by 180 degree. And then the answer will be 5 pi by 180 degree. This is going to be our answer. Similarly, this sine 1 degree will be first written as sine of pi by 180 degree. And then we are going to write it as pi by 180 degree. And if you remember, we have written it, it was somewhere around 0.002. At the very start of the chapter, we have written this. Got it? So please note when I am saying that this theta should be in radian, not in degree. Clear? Again for tan 2 degree. First we are going to write tan 2 pi by 180 degree. And then we are going to write, I mean you don't have to write degree over here. Then you are going to write pi by 90. Pi by 90, not degree anything. Cos 1 degree is simply 0. Cos 5 degree is 0. Cos 7 degree is 0. What is sine 15 degree? What is sine 15 degree? We cannot use approximation formula over here. We cannot use approximation formula over here because 15 degree is not a small angle. 15 degree is not a small angle. So either use sine table, use calculator, or use compound angle formula. Got it? Clear? Be quick. All done and dusted. Now let's talk about last rule for trigonometry, that is sine rule and cosine rule. Again, let me tell you, we are not going to extensively use this, but it is important. First one is sine rule. Now this is for any triangle. This is true for any triangle. Valid for now. Don't get confused. Don't say ki sir, but you said ki sine, cos, all of these things are only for right angle triangle. Please understand one thing. If we have got a triangle, let's say this side is 45 degree, or let's say this side is 40 degree, this side is 60 degree, and this side is 80 degree. Then we can find out the value of sine 40. No one is stopping you to find out the value of sine 40. It doesn't mean that you cannot find out the value of sine 40 unless and until we have got a right angle triangle over here. Got it? So this is valid for any triangle. The sine rule says that if you have got a triangle, this angle is capital A, the side opposite to this angle is small a. Similarly, this angle is capital B, side opposite to this is B. This angle is capital C, side opposite to this is C. So the ratio of sine A upon A, sine of angle divided by opposite side is constant. Sine A upon A is equals to sine B upon B is equals to sine C upon C. Very simple. Valid for any triangle. Similarly, cosine rule. Cosine rule is also valid for any triangle. Let's suppose, my dear friends, we know this angle. This angle A is given, right? And we want to find out A or any other side. So we can write down A square equals to B square plus C square minus 2BC cos A. Kindly remember this B and C, and this is the included angle. This is the angle made between B and C. So these are simple rules. You can remember these. Again, let me repeat it. It's not like we are going to use it a lot. One question. Come on, solve it. Be quick. Sort of. Yes, Umar. Absolutely. Absolutely. It is same. Find the answer for this one. We need to find out the value of x. So sine 90 degree divided by x is equals to sine 37 degree divided by 3. That's it. I mean, you don't need to use any other law. You can also use cosine rule. X will be equals to 3 divided by sine 37, as sine 90 is 1. So 3 divided by 3 by 5. That's going to be 5. Now you can also use cosine rule. Hai na? You can also use cosine rule. You could also say, sir, this is a right angle triangle. I am simply saying it. I've simply given it so that you can use cosine rule and sine rule also. Now use cosine rule in homework. Cosine rule in homework. Now let's start differentiation. differentiation. All right. Calculus started. Although in our normal lectures, when we start differentiation, we start with many things, but I'm going to straight away start with the geometrical meaning of differentiation. What do we mean by differentiation geometrically? So let's start with x-axis and y-axis. Let's say we have got x-axis, we have got y-axis, and let's suppose we have got a straight line like this. Let's suppose we have got a straight line somewhat like this, right? If I want to know del y by del x, if I want to know del y by del x of this straight line, del y basically means y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. Pay attention. This thing can be also called as average rate of change. This dy by dx can be also called as average rate of change. And what is y2, y1, x2, x1? These are simply 2 points, any 2 points. Let's say we have got 2 points. This is x1, y1. This is x2, y2. Right? x1, y1, x2, y2. Now, when you are going to join these 2 points, we'll make a right angle triangle. And this side is going to be y2 minus y1. Hopefully you all can understand. Definitely this entire thing is going to be y1. From here till this point it is y1. From here till this point it is x1. This is, sorry, this is y2, my bad, this is y2, this is x2. This is x1, this is y1. So this is y2 minus y1, this is going to be x2 minus x1. This is going to be x2 minus x1. This length is x2 minus x1, this length is y2 minus y1. So y2 minus y1 divided by x2 minus x1 can be also written as tan theta. It can be also written as tan theta if you will closely see, because tan theta is nothing but perpendicular upon base. Perpendicular upon base. Tan theta is very important for us. We are going to use it a lot. Instead of now tan theta, we are going to also call it as slope of the graph, slope of the curve, slope of the curve. It has got different names: slope, gradient, right? We can also call it as gradient, or del y by del x. Clear? It has got different names. Sometimes we write it as small m when we are talking about equation of straight line. Now the point is, in a straight line has this special thing that this angle will remain constant. Let's suppose this angle is theta, right? This angle is theta, tan theta is p upon b. Now wherever you want to find this slope, slope will basically mean angle from positive x-axis in the anti-clockwise direction. So this will be also theta. This angle will also be theta. Anywhere you will go, angle will remain same, right? So this is known as average rate of change, that is del y by del x, that is tan theta. See, things will be different when we are going to talk about a curve. Let's suppose now we don't have a straight line, we have got a curve like this. We have got a curve like this. And now in this we want to find out slope at any point. This is, let's suppose this is x-axis, this is y-axis. We want to find out slope at any point. Let's suppose we want to find out slope at this point. Or let's suppose we are choosing 2 points like that. We are choosing point A and we are choosing point B. So this point is x2 comma y2, and this point is x1 comma y1. Let's make same type of triangle over here. Pay attention, same type of triangle over here. Somewhat like this. And let's join these 2 points like this. By the way, this line is known as secant. This line is known as secant. If I'll find out del y by del x for this curve, I can again say this is an average rate of change. Average rate of change. I can again say the same thing. Average rate of change. But can I say that? Can I say this theta is the slope for the curve? Can I say this theta is the slope, tan theta is the slope for the curve? I cannot say that. Obviously, you can see ki that theta is not the slope for the curve. I'm going to make one more diagram for you. Pay attention. I've made a copy of this. I am going to bring all of these things over here. Right now, I don't have use for this. Let's remove this and let's make a copy of this again. See, I am explaining it you in a mathematical way, and that is the best way, right? So you must pay attention, my dear friend. What I'll try to do is I'll try to remove these things for a moment. Now I'm saying if I want to find out slope at any point, what I'll do is if I want to find out slope at this point, I'll draw a tangent over here. I'll draw a tangent over here, a tangent like this, a tangent like this. And I'll draw an axis parallel to x axis and I'll find out this theta. Let's say this theta is theta 1. So at point A, slope is actually tan theta 1. This is slope at point A. If I want to know slope at any other point, I'm going to draw the tangent at that point, or something like this. Again, an x-axis. Let's say this angle is theta 2, and this is point B. So slope at point B is going to be tan theta 2. This is slope at point B. This is slope at point B. Clear? But I cannot call this as slope of the curve now. I cannot call this as slope of the curve, although I can still call it as average rate of change. That is, the average rate of change between point A and point B is del y by del x. That is absolutely fine. But what if I need to know slope at every single point? This is why we use differentiation. I am actually cutting the theory down. I am cutting all the concepts from mathematics and we are coming back to our use of differentiation. When we are going to talk about differentiation of any function, we want to find out slope at any point. What's wrong with this formula? The drawback of this formula is that we can use it for a straight line, because for straight line slope is constant, slope is same at every single point. But when we are going to talk about a curve, we cannot simply apply y2 minus y1 upon x2 minus x1, because we can see slope is ever changing. At every point slope is changing. So we will require a method which is known as differentiation. In mathematics, there is a complete chapter of limits. Then we talk about differentiability, then we talk about continuity, then we talk about differentiability, and we learn to differentiate a function. We are not going to do all of those things. you are going to simply understand what do we mean when we say dv by dx. Everyone knows this dy by dx. So this is nothing but, this is actually nothing but a modification to del y by del x. It is nothing but a modification to del y by del x, right? So wherever you are going to see a symbol delta, it means that we are talking about a finite change. Wherever you are going to see the symbol delta, this means that we are talking about finite change, right? Finite change. And wherever you are going to see dy, this basically means, this dy basically means infinitely small change, infinitely small change in y with respect to x. And what is dx? This is infinitely small change, infinitely small change in x. Got it? Clear? Done? Just one more graph, then we'll go back to the rules of differentiation. Let's suppose we are talking about a curve somewhat like this. Somewhat like this. Let's choose a point over here. Let's say the coordinates of this point is x comma y. Coordinates of this point is x comma y. This is x. This is x. This is x. Got it? Done? Now let's say, let's write another x. Let's write another x somewhere over here. Somewhere over here. And the coordinate of this x, of this point is x plus dx. Dosto, my point is this x plus dx is actually x plus 0.000000000000000001 x, or sorry, 0.0001. That means an infinitely small increment, a very small increment in x, a infinitely small increment in x. Although you are going to say, sir, this looks like finite value, but I have exaggerated it just so that you can see the diagram clearly. Just so that you can see the diagram clearly, I have said this is x plus dx. But whenever you are going to see dx, it means that it is a very small change, infinitely small change. Got it? So let's suppose if you have got an infinitely small change in x, with respect to this x, you are going to have a different y also. And this is going to be y plus dy. This is going to be, see, this was your initial y. This was your y. This was your x. Now this point is going to be y plus dy. Y plus dy, and this is x plus dx. So the coordinate of this is x plus dx comma y plus dy. So when you are going to join these two, now pay attention. Now these 2 points are so close to each other that I can imagine this thing as a straight line. Got it? Are you able to understand this? Radius of Earth is 6,400 kilometer. 6.5 into 10 to the power 5 meter. 6,400 kilometer. That's why whenever our eye sees on a plain ground, our eyes can see up to a distance of, on a plain ground we see up to a distance of 1 kilometer, 3 kilometer, 10 kilometer. We see that everything is flat. So I am saying that this distance is so small. Instead of talking about a curve, I am going to say it is a straight line. I am going to say it is a straight line. Got it? This is a straight line. So if this is a straight line, this is going to be base. This is going to be perpendicular. This is going to be dy. This is going to be dx. This is going to be that angle theta. That's why we write slope as dy by dx. That's why we write slope as dy by dx. Got it? There are different ways of writing it, explaining it. In books, you are going to also see something like this. In different books, you are going to also see something like this, that limit delta y by delta x as delta x tends to 0. They are saying here, this is delta x, this is delta x. So delta x is tending to 0. This term means it is tending to 0. It is almost becoming 0, not equal to 0. These are two different things. Huh? Tending to 0 means it is almost 0 but not 0. So if delta x is going to become smaller and smaller and smaller and smaller, b will come closer and closer, closer and closer, closer and closer, and at a point b and a will be almost at a single point, and we can make a tangent at that point, and slope of that tangent will be slope of the curve at that point. If you can't catch all of these things, pause the video after the class will get over and come back. If you are going to learn it like this, physics will become easier after a while. Okay. So this is why we use dy by dx. Now let's talk about these notations. These are different notations. These are different notations, my dear friends. All right. These are different notations. You can call it as dy by dx. We can call it as d of f of x by dx, or differentiation of f of x by x. So y and f of x means the same thing. Why? Sir, why we not say limit dy approaches to 0? Because dy is not approaching to 0. Dx is approaching to 0, and dy, we are finding what dy is going to be. We are not saying that. Actually, we should say that change in y with respect to infinitely small change in x. That's what we should say. Right? Clear? So dy is not approaching to 0. Dx is approaching to 0, and corresponding to that, we are going to find out the change in y. That will be also very small. That will be also very, very small. Right? So these are different notations. We are going to only use these two. We are going to only use these two. Sometimes, somewhere we can also use y dash. Sometimes we can also use y dash. This y dash or f dash of x or dy by dx or differentiation of f of x with respect to x all have same meaning. All have same meaning. Y dash, f dash of x, dy by dx all have same meaning, right? Now, let's see some standard results. First result is power rule. First result is, my dear friends, power rule. Power rule is x raised to the power n. If you want to differentiate x raised to the power n, let me use a fresh page for this. First rule is power rule. This is for polynomial function. This rule basically says, if y is equals to x raised to the power n, if y is equals to x raised to the power n, then dy by dx will be nx raised to the power n minus 1. This is the rule. Nx raised to the power n minus 1. Example, let's suppose y is equals to x raised to the power 2. Y is equals to 1 upon root x. Let's suppose y equals to 1 upon x raised to the power 3. So differentiation of this will become y dash, and this will become 2x raised to the power 2 minus 1, that is 1. By the way, 1 upon root x can be written as x raised to the power minus 1 by 2. And differentiation of this will become minus, power will come down, x raised to the power minus 1 by 2 minus 1. So this will become minus 3 by 2. This thing can be written as x raised to the power minus 3. So y dash will be written as minus 3 will come down and x raised to the power minus 4. Clear, my dear friends? Any doubt? All sorted? If let's suppose an extension to this, if let's suppose you have got y equals to some constant k x raised to the power n. So we'll have no problem. We'll simply multiply this n with k. We'll have no problem, right? So y dash will become n will come down, n multiplied by k x raised to the power n minus 1. This is the root, right? Another example. Let's suppose you have got y equals to 3x square. So y dash will become 2 will come down, it will get multiplied with 3, x raised to the power 2 minus 1, that is 6x. That's it, 6x. Clear? Quickly write down. X raised to the power 5, x raised to the power 5 will be 5x raised to the power 4. X raised to the power 1 by 4, this is x raised to the power 1 by 4, it will become 1 by 4 x raised to the power 1 by 4 minus 1, that is minus 3 by 4. Done? 1 by x, in differentiation of 1 by x. 1 by x can be also written as x raised to the power minus 1. So it will become minus x raised to the power minus 2. That means minus 1 upon x square. Minus 1 upon x square. X raised to the power 1 by 2. Now we have already solved it. 1 by 2 x raised to the power minus 1 by 2. Or 1 by 2 root x. 1 by 2 root x. 1 by 2 root x. Clear? By the way, if someone tells you let's suppose y is equals to 3x. What is differentiation of this? What is differentiation of y equals to 3x? Y dash will become 3. Also, you can straight away see this, that this is nothing but a straight line. This is nothing but a straight line. And straight line standard form is y equals to mx plus c. Here m is the slope. Here m is the slope. So I have told you differentiation is only used to find out slope for any curve. Straight line is also a curve, right? Clear? Having zero number of turns, it will not turn. So a straight line, this is applicable, right? This differentiation is applicable for that also. What is, now if you are going to draw a graph of 3x, it will look something like this. It will look something like this. This is the equation, and this angle theta is going to be, what is theta? Tan theta is equals to 3. So theta will be tan inverse 3. Theta will be tan inverse 3. Right? Acha, what is the equation of this graph? What is the equation of this graph? Quickly let me know. This is 5. What is the equation of this graph? Y equals to 5. Second example is y is equals to 5. What is differentiation of a constant? What is differentiation of a constant? You are going to say, sir, constant can be written as 5 times x raised to the power 0. So y dash will be 0. That means slope is 0. So I'll say that we can see with our naked eyes. This line is parallel to the x-axis. Angle made between x-axis and this line is 0. So we can also see this with our naked eyes, that slope of this graph is 0. Theta is 0, tan theta is 0, right? Done? Clear, my dear friends? So we can always check with the knowledge of graphs, right? Pay attention. Y equals to x square. What is differentiation of y equals to x square? What is differentiation of y equals to x square? What is differentiation of y equals to x square? Y dash is going to be 2x. Y dash is equals to be 2x. That means, pay attention. Huh? We are discussing about slope. This is slope or tan theta. All of these are synonyms here. All of these are synonyms, right? My dear friends, y dash will be 0 at x equals to 0. Y dash will be 0 at x equals to 0. Y dash will be positive for x greater than 0. Y dash will be negative for x less than 0. Correct? Right? Now let's draw the graph of this. Please don't mind the graph, but x square graph will look something like this. Is that clear? I have told you one simple thing, that if you want to find out slope at any point, draw a tangent at that point. Let's find out slope at x equals to 0. So let's draw a tangent at this point. We are going to use pink line for tangent. So this is a tangent. See, this line looks parallel to, it is exactly parallel to x-axis. Parallel to x-axis. That means slope is 0. So at x equals to 0, slope is 0. According to our graph and according to differentiation. If x is greater than 0, if x is greater than 0, x is greater than 0 means this axis. If x is greater than 0, draw a tangent at any point. Draw a tangent at any point. Let's draw a tangent at this point. Let's draw an axis parallel to x-axis. Let's draw an angle like this. This is an acute angle, always an acute angle, less than 90 degree. Tan less than 90 degree will give you positive value because first quadrant. See how things link. Tan theta, and when theta is acute, then tan theta will be positive. Let's take any point over here where x is negative. Let's make a tangent at this point. Let's draw an axis like this. Let's mark an angle like this. Angle is greater than 90 degree. Greater than 90 degree means first quadrant. In first quadrant only sign is positive, tan is negative. So over here for all these x's, for all of these x, tan will give a negative value. That means for all of these ones, slope will be negative. Slope is negative for x negative. Is it clear? Right? Done. So you need to understand each and everything. We are using formulas, but at least we can see how it will work in graph. We won't be able to find out the exact value at this point. That is, we are learning differentiation rules. Got it? We can't find out exactly the value of theta at this point, you by looking at the graph. So that's why we are using these rules. Differentiation of a constant is 0. Differentiation of a constant is 0. Right? I'm still at 0. Huh? Come on. Which language is this? Sure nin photo haka. Which language is this? Someone has written, bro, I'm a boy. Yantha bro, name Beka Yav Ru Beka. I don't know what I'm saying. It might be offensive also. I don't know. I don't think you're talking about physics here, huh? Because at least you have used body pain in your sentence. I don't think so. You're talking about physics. All good? Clear till here? Sir, are you not tired? I did legs today in gym, so I'm slightly tired because of my legs. But other than that, no, I'm all good. Sir, it is Kannada. Okay, ठीक है. Sir, Paro. Sir, they are talking about name and city name. I'm tired with all of these things. That's why I think let's read your chat. It looks more interesting than tan theta, dy by dx, all of these things. Those chats are slightly more interesting. Take rest. We'll end this calculus and then we'll take rest. Thank you, sir, for nahi. Sir, read it once again, please. Sir, what time lecture will continue? Sir, do you still remember me? Hame Bakery. What's your real name, buddy? Sir, please have a seat for 5 minutes. I don't have a seat in my studio right now. All cool. Shall we begin? Thank you. Thank you. Vectors today, I have already, we have already discussed it. Vectors was not possible in one lecture. We'll take vectors some other day, right? Sir, will you give free lectures for all chapters on YouTube? Well, almost all chapters on YouTube, yes. But we are not going to go topic wise, but definitely entire content will be available on YouTube on PW NEET English channel. But there is going to be a difference. All the students who have watched these lectures in Yaqeen NEET English batch, they can attest to this, that I am explaining all the things, but surely we are moving with a lot of speed. Like I have explained all of these concepts. Maybe I have given 5 more examples. Right now we are only talking about 2 examples. So there is only difference in the number of examples. That's all. Sir is chit chatting. I am also got bored here with all of these things. I said, na, your chat is looking more interesting. Okay. Somebody has written Tadi. Tadi I know, yaar. Tadi is a drink. Sir, you know Smita ma'am? No, I don't know Smita ma'am. You should buy, sir. I should buy Tadi. Okay. Maybe on weekend. Maybe day after tomorrow. Let's move now. Hopefully everything is clear till this point. Now let's also talk about other rules of differentiation other than polynomial function, right? Tari. Tari means name, na? She was saying Tadi. Sir, your Kannada is nice. Sir, how to do physics? Sir, where is Shalini ma'am? Shalini ma'am is in Bangalore, I believe. How to approach physics? Keep on trying. One day, physics heart will melt and she will say yes. I mean, it will depend for you if you think physics is she or he. But one day, she or he will say yes. You will have to keep on trying. Now, let's see. Let's come back. Class will end after integration. Class will end after integration. Friends, these are the rules for differentiation, right? Differentiation of sin x is cos x, differentiation of cos x is minus sin x, and tan x is sec square x, and cot x is cosec square x. But I only want you to look at differentiation of sin x, it is cos x, and differentiation of cos x is negative times of sin x. And after this, we will first discuss quotient rule, and then we are going to talk about quotient rule and product rule, and then we are going to talk about differentiation of tan x. So, next rule is quotient rule or division rule. Division rule. You can also call it as quotient rule. Kindly see. Notes will be provided, don't worry. Notes will be provided. If notes are not provided, kindly comment in the kindly write down in the comment section, but it will be provided on WhatsApp NEET channel, in PW NEET English channel. Division rule, pay attention. Let's suppose we have got y equals to g of x divided by h of x. G of x divided by h of x, right? So we have got two functions. We have got two functions, g of x divided by h of x, and y is the answer of this. That means y is f of x. F of x can be written as g of x divided by h of x. This thing can be called as u. This entire function can be called as u. This function can be called as v. U, this can be called as v. So y dash will be written as differentiation of u. Let's keep y as it is, minus sign. Let's keep u as it is, differentiation of v divided by square of v. Divided by square of v. Got it? Let's take an example. Let's suppose we are talking about y equals to tan x. And tan x can be written as sin x upon cos x, right? And we want to find out the differentiation of y. That means we want to find out the derivative of tan x. By the way, derivative, first derivative, second derivative, we are going to talk about that also. For now, you can understand this, that if we are differentiating a function for a first time, we are going to call it as first derivative. If you are going to again differentiate it, that means after differentiating it once, you are going to differentiate that function, that will be called as second derivative, right? So differentiation of tan x will be, actually we can write it as differentiation of sin x divided by cos x. Correct? So now the rule says, my dear friends, First, let's say that this is u, this is v, u and v. Now the rule says differentiate the numerator or u, let's write denominator as it is, put up a minus sign, let's write numerator as it is, and let's write the differentiation of denominator now, divided by the square of denominator. Just now I have told you, you need to only remember two formulas from differentiation of trigonometric ratios, that is differentiation of sin x is cos x and differentiation of cos x is minus sin x. You can ask me ki, where is the derivation for these two things? Derivation is not in our course, but again you can understand it graphically if you are going to look at the graph of sin x and you are going to see how slope is changing at different points and you are going to try to plot that. Obviously you are not going to try that, no one should try that, but if you will think about it, the variation of slope of sin x exactly looks like cos x, and variation of slope of cos x looks like negative times of sin x. So you need to remember at least these two and then we can apply it over here. Differentiation of sin x is cos x. We have written cos x as it is, it becomes cos square x. Differentiation of cos x is minus sin x. So this minus will become plus, it will become plus sin square x divided by cos square x. Sin square x plus cos square x is 1. So it will become 1 upon cos square x. 1 upon cos is sec, so this will become sec square x. This will become sec square x, right? Done? All cool? Do you teach BTech differential equation? No. No. Done? Now, next is, let's talk about differentiation of cot x. Differentiation of cot x. So differentiation of cot x can be written as differentiation of cos x upon sin x. Differentiation of cos x upon sin x. Again, my dear friends, same thing. Differentiation of numerator. Let's write denominator as it is. Put up a minus sign. Let's write numerator as it is. Let's write differentiation of denominator. And divided by square of denominator. Differentiation of cos x is minus sin x. So sin x will become minus of sin square x. Differentiation of sin x will become cos x. This will become minus of cos square x. Answer is over here. This will become, let's take minus common. So it will become sin square x plus cos square x whole divided by sin square x. This means that minus 1 upon sin square x or minus cosec square x. Minus cosec square x. So now we can go back to that table. I have told you to remember at least these two, right? I have told you to remember at least these two, and tan x can be written as sec square x, cot x can be written as minus cosec square x, sec x and cosec x. So for sec x, my dear friends, it will be 1 upon cos x, differentiation of this, right? Do it in homework. It is very easy. Differentiation of 1 is 0, differentiation of cos is minus sin x. This is differentiation of 1 upon sin x. I believe you can do this as well. Clear? After this, there are only two functions which are left out. One is exponential function. For exponential function, my dear friends, remember that the differentiation of exponential function is exponential function itself. The differentiation of exponential function is exponential function itself. The differentiation of natural log is 1 upon x. This is important. The differentiation of natural log is 1 upon x. Natural log is remaining in this chapter. We have not completed it. I'll mix that natural log with vectors and we'll complete that. All right. Any more doubt in any of these, let me know. Now let me explain you along with let's see, yeah, product rule. PC. Product rule. Let's say y is written as g of x multiplied by h of x. G of x multiplied by h of x. Right? And let's say this is first function u, this is the next function v. So the product rule says y dash, you are going to write it like differentiate the first function, let's write second function as it is, plus let's write first function as it is, and let's write derivative of second function. This is product rule, right? Let's see some examples. By the way, quickly solve this. Quick, in the chat box, answer in the chat box. 3 cos x f dash of x. 3 cos x will be written as 3 of minus sin x minus of 7. Differentiation of sec x is, my dear friends, differentiation of sec x is sec x tan x. So 7 sec x tan x plus 4 will come down, 4 5s are 20, 20x cube plus 0, differentiation of constant is 0. So this is going to be your answer. Is it clear? It is visible, na? Question is visible. Come on. Let me know in the chat box. Solve for this. Find out the differentiation of x log x. X log x. Find out the differentiation of x log x. Y dash will be differentiation of x. Let's write log x as it is, plus sign different x and differentiation of natural log x. So this will become natural log x plus x, and this will become 1 upon x. Cancels out, answer comes out to be 1 plus natural log x. Or you can also write it as 1 plus log x to the base e. There is no point of writing log x to the base e. We can simply write it as natural log x. We can simply write it as natural log x. Clear? Done? Moving on. Come on, find the answers for these ones. Wait, Kumar, we are going to talk about integration just now. Wait till then. Differentiation of x sin x. So differentiation of x sin x will be differentiation of x. Let's write sin x as it is, plus x as it is, differentiation of sin x. This will become sin x, because differentiation of x will become 1, sin x plus x cos x. So the first answer is going to be sin x plus x cos x. First answer is this. differentiation of this will become y dash will become e to the differentiation of e to the power x cos x as it is plus sine e to the power x as it is differentiation of cos x. This will be y dash. For the second one is going to be differentiation of e to the power x is e to the power x, right? Differentiation of e to the power x is e to the power x itself, and then cos x as it is, and differentiation of cos x is negative times of sin x. So this will become e to the power x and sin x, right? So e to the power x will be taken as common, and cos x minus sin x. No, you have compared with, you have done a very wrong comparison, right? The name of teachers that you have taken, I know them personally, and you are absolutely wrong, let me tell you. Okay, although thank you, but your compliment is not in a good taste, bachche. You must not compare teachers, and even if you are comparing me, that is a wrong comparison. I mean, I'm saying it rationally without any emotions. It's a complete wrong comparison. They are far better than me. Now, x divided by 1 upon x. X divided by 1 upon x. Now, let's use quotient rule. Differentiation of x, let's keep denominator as it is, minus sign. Then let's differentiate denominator and keep numerator as it is, divided by square of denominator. I am not going to simplify it, but hopefully you can understand. Differentiation of x becomes 1, it will be 1 plus x minus differentiation of 1 plus x. Doston, differentiation of 1 plus x, differentiation of 1 will become 0, differentiation of x will become 1. This will be simply x divided by 1 plus x whole square, right? So x and x will get cancelled out. We'll get 1 upon 1 plus x whole square, right? Clear? Done? Fourth one again we are going to talk about product rule. Root x sin x. Let me solve it over here. Y equals to root x sin x. Product rule dosto. Let's differentiate first root x, and we are going to keep sin x as it is. Then plus sign, then we are going to write root x as it is and differentiate sin x. Differentiation of root x will become 1 upon 2 root x. Got it? Now we can quickly write down the differentiation of root x. Sin x as it is plus root x, differentiation of sin x is cos x. No need of simplifying it further. This is our answer. Clear? Next is chain rule. Chain rule is also very, very important. Extremely important. We are going to use chain rule when we have got a situation somewhat like this. Kindly see those. We'll try to end it at 12, but let's see. Dosto, let's suppose we have got a function something like this, f of g of x, right? A function like this, f of g of x. These are also known as composite functions. Let me give you an example. Let's suppose example, f of x is sin x and g of x is, let's suppose g of x is natural log x. Clear? G of x is natural log x, or let's say x square, 2x square. Now if someone will say what is f of g of x, then this will mean sine of 2x square, sine of 2x square. But that's not the point. Don't get confused with all of these things. This is not what we are going to learn. We are going to learn that, let's suppose you want to differentiate y equals to sine of 2x square. How to differentiate this? Right? How to differentiate this? This is what we are going to learn. So what we are going to do is differentiation y dash equals to, differentiation y dash is equals to what you are looking at. First you are looking at sine. First we are looking at sine. First we are looking at this function, that is sine. What is differentiation of sine? Differentiation of sine is cos. So differentiation of sine is cos, and then write everything which is inside of that function, that is 2x square, and then use a multiplication sign, and then let's go inside. What is differentiation of 2x square? It is 4x. So the answer will come out to be 4x cos 2x square. Kindly don't multiply this 2x with this 4x. This 2x square is angle, this 4x is outside of this whole thing, right? Let me give you some more examples. Let's suppose we want to differentiate this, right? So outer function, we have got two functions, huh? One is outer function, one is an inside function. Outer function is this. This is outside function. This is outside function. First thing that we are going to do is, we are going to write y dash is equals to, power will come down. We are going to write everything as it is. Whole raised to the power 4. Why 4? Because 5 minus 1. Then multiplication sign, then we'll go inside. Differentiation of 3x will become 6x. Differentiation of 2x will become 2. Differentiation of 3 will become 0. So finally the answer will be 5 multiplied by 6x is 30x plus 10 multiplied by 3x square plus 2x plus 3 whole raised to the power 4. I am going to give you this question in homework. This question in homework. These two are easy. This will become 6 times 2x plus 3 whole raised to the power 5 multiplied by 2. So answer will become 12 times 2x plus 3 whole raised to the power 5. That one, dosto. Last one. E raised to the power anything. E raised to the power anything is same. That means we are going to write e raised to the power 5x plus 2. But now we are going to go to the inside function and multiply it by 5. That is differentiation of 5x plus 2. So answer will come 5 times of e raised to the power 5x plus 2. 5 times of e raised to the power 5x plus 2. Any doubt? Clear? Lots of problems for you, for your practice. First one, sine of t plus 2. It will become cos of t plus 2 multiplied by differentiation of t is 1, differentiation of 2 is 0. That means answer will be simply cos of t plus 2. Now these are slightly challenging, slightly, not a lot, but slightly. Like for example, as cos 2 theta, and we want to find out dy by dt. Pay attention. If you want to find out dy by dt, this will become differentiation of cos 2 theta, divided by dt. Kindly note one point. We cannot simply write down differentiation of cos 2 theta as, first of all, pay attention. If I'll ask you what is differentiation of cos 2 theta, this is very important. Huh? If you'll ask, I can also start integration in next class. There is no problem, because I said that we are going to take the class till 12 and we are only able to complete till differentiation. So we'll take up part 2 of it and we'll club vectors. But this is very important, pay attention. If I am saying what is differentiation of cos 2 theta, it means that, without saying, it means that I am talking about differentiation of cos 2 theta with respect to theta. If I am saying what is differentiation of cos 2x, then without saying it, I am trying to communicate that what is differentiation of cos 2 theta with respect, differentiation of cos 2x with respect to x. So this answer will be differentiation of cos is minus sine, so minus sine 2 theta, and then differentiation of 2 theta is 2, so the answer will be minus 2 sine 2 theta. Similarly, answer is going to be minus 2 sine 2x. Got it? Right? We are trying to differentiate cos 2x with respect to x. We are trying to differentiate cos 2 theta with respect to theta. But here things are different. Here we are trying to differentiate cos 2 theta with respect to t. It is not possible. It is not possible, na? We cannot differentiate cos 2 theta with respect to t. Got it? So pay attention. Now what we are going to do is, we can differentiate theta with respect to theta. We can differentiate cos 2 theta with respect to theta. So we are going to use a very common mathematics method, manipulation. Let's multiply and divide with d theta d theta. Next step is going to be, now let's rewrite differentiation of cos 2 theta with respect to theta, and let's write one of the d theta and dt separately. Now differentiation of cos 2 theta with respect to theta is minus 2 sine 2 theta, and d theta by dt is given in the question, it is omega. So it is omega. So this is our answer. So my final answer is going to be minus 2 omega sine 2 theta. This is extremely important. We are going to use all of these things. If you remember, my dear friends, acceleration is written as dv by dt. But if I am going to multiply dx and dx, I can get dx by dt multiplied by dv by dx, right? So dx by dt is nothing but velocity, so v dv by dx. I mean, if you don't remember this, no problem. If you are in class 11th, then also no problem. All right, clear? Done? Now these questions in homework, and after this we are going to start from part 2. I'll break this basic maths in 2 parts, next in part 2. All right, integration in vectors in part 2. Let me know if everything is clear. You will get these notes, don't worry. I'll ask the team to paste the notes in the description box. Okay, don't worry. Is dx by dt is equals to dx by dt? Yes. All cool? Done? Chalo. Then we'll continue from here. Continue from here in our next class. All right. Okay, cool. Bye everyone. Bye, 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 bye. Thank you so much. And see you in our next class. All right. If you have any other requirement, do let me know in the comment section. Bye, bye, bye. I know integration is hard, but I mean, if we had time today, surely we would have done it. But now, wait for next class. In next class, we'll do integration. Okay. Chalo. Bye, bye. Bye, everyone. Bye, 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 bye. Good night. Good night. See you tomorrow in batch. Take care. Bye, 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 bye.